right, so for Module 3, Lesson 1, you'll notice that there's a lot of stuff at the beginning where you're folding paper lots and lots of times and figuring out the width. We're not going to do that because it's a cool exercise, but we really need to be careful about how much time we use on each and every lesson this semester. Because we got a lot of testing and stuff coming up. We're going to need to really, really maximize the amount of time, or the time that we have in class. So I'm just going to go ahead and write down some properties of exponents for you right away, and then we're going to use it. So here we go. All right, so our first property you guys have used before, and it is that if I have some a to the m times some a to the n, that's equal to a to the m plus n. All right, keeping in mind just some vocabulary. This right here is our base, and this right here is the no, it's the exponent. We have our base and our exponent. So for each one of these properties, I will also give you a corresponding example. So for example, with this one, if I have x to the second power times x to the third power, this is going to be equal to x to the 2 plus 3 power, same thing as x to the fifth, right? You guys have used this property before. It's probably just a refresher from Algebra 1, but it's good to get a refresher. Our next property we're going to use is that if I have some a to the m to the n power, that's going to be the same thing as a to the m times n. So my example would be that if I had x to the second power to the third power, that's going to be the same as x to the 2 times 3 power, which is x to the 6. Property number 3 says that if I had some a times b to the m power, that's going to be the same thing as a to the m times b to the m. So in other words, I'm taking that exponent and I'm raising everything in the parentheses to that exponent. For example, if I have some, if I have 3x to the third power, I need to raise both the 3 and the x to the third power, which means this is going to be 3 to the third power times x to the third power, or x cubed. And 3 cubed is 27. And again, that's something that you've already used, so we're just going to refresh that for your memories. All right. Property 4 says that if I have some a to the negative m power, that's the same thing as 1 over a to the positive m.
Negative and m is a negative. So it's like
it would become positive. No, that's good. That's a good question. You will come across that. All right. So, for example, if I had x to the negative 2 power, this is the same thing as 1 over x to the positive 2 power. Number 5. If I have some a to the m over a to the n power, what I'm going to do is go ahead and subtract those exponents. So this becomes a to the m minus n So for example, if I had x to the 5th over x to the 3rd, this becomes x to the 5 minus 3 power, which is the same thing as x squared. And our last property, which you just barely had room in here for, is that if I have anything to the 0 power, it's 1. Anything to the 0 power is 1. We all know that already. My example, though, that I would use for that is that if I had 16x squared y z to the 14th to the 0 power, that's 1. Right? Because anything to the 0 power is 1. So it's tricky. Sometimes you'll get something like that. You'll think you need to do stuff to it. You know, it's just 1. Alright, you guys ready to apply some of these? Let's do it. Whoa. Here we go. All right. And so this one is indeed in your module. You got to skip through a couple pages. One more. Oh, there it is. Sorry. Okay. So when I use properties of exponents, I like to break the thing up. So in my mind, I'm breaking it up and putting similar pieces together, performing these operations, and then putting it back together. And so I'm going to do that. That's the way I approach it. Some of you might be able to see this already in your mind, but I'm going to do every single little step. So I'm going to take this. So this says 5 times x to the 5th times negative 3 times x squared. The only operation in this thing is multiplication. Even though there's a minus sign in there, the only operation we're using is multiplication. So that means that I can reorder this. So I can say that this is 5 times negative 3 times x to the 5th times x squared. That's fair. I haven't violated any rules of mathematics. And that just allows me to kind of look at the pieces separately, right? So now I see that there's a 5 times negative 3 in there. So I need to have a negative 15. And then I'll apply my property 1 to this. So this becomes x to the 5 plus 2 power, or negative 15 x to the 7. Right? No problem. All right. So for this one, I want to break it up, but I can't yet because this 2x is kind of locked in there by the 4, by that 4th power, I should say, right? And the reason for that is that my order of operations says that I can't do multiplication before I do exponents, right? I have to deal with this exponent before I can take stuff out, right? Because really when I broke this top one out, letter A out, I was using multiplication, right? I was using a property of multiplication. I can't use a property of multiplication until I dealt with my exponents first. So let's do that. So I'm going to use property 3 first. Or was it? Is it 4? Nope. Check it out. Here we go. I'm using this guy first, property 3 first. I have to distribute that exponent. I gotta distribute that exponent. Where did I say? Alright. So this becomes 2 to the 4th power times x to the 4th power, right? Okay, so now what is 2 to the 4th power? 16, so this is 16 x to the 4th. Now I've dealt with all of my exponents that I can, right? Every exponent that I could simplify, I've done in there. So now it's time to break this thing up. It's not necessary to do this for this one, but I think it helps you to see things by looking at the individual parts. So then this becomes 3/16 times, and this is x to the 5 minus 4 using property 6. 5. All right. So that is 3/16 x to the first power, right? I'll just leave it. All right. Ready? Learning is good. All right. Here we go. So again, I have some stuff going on in here. I have to follow my order of operations. I have to deal with my exponent first, right? So I'm going to write this as 3, and this is x to the 2 times -3, right? X to the 2 times -3. So this is 3 over x to the -6 power. We can further simplify this because x to the -6 is the same as 1 over x to the 6. So I'm going to write a weird fraction here. Actually, let's write it like this instead. And then it'll look better. I think it's nicer to kind of, if I'm going to use the property of exponents, I'm going to separate the thing out that I'm using the property on. And that way, it just doesn't get jumbled up. Yeah, here. So this is what's happening. Isn't this, so the top 1 is the same thing as 1 over 1, right? Actually, let's not do that. This is 1 over x, right? So the x to the -6 became 1 over x to the 6, right? Yeah. So check it out. So this is this. That's all I did. Okay? All right. So now I have to flip and multiply it, right? This says 1. This says 1 divided by 1 over x to the 6, right? Yes. So 1 over x to the 6. Okay, that's cool. So using property number 5, that's true, right? Yeah. It does. That is true. Good question. Does that make sense? So that's how I went from here to there. All right. So now I need to flip this thing and multiply. So just leaving that, and then this is separate. So this is actually, this is my numerator, okay? 1 is the same as 1 over 1. I need to flip and multiply, so and I'll write a slide explanation. So this 1 over 1 over x to the 6 is the same thing as 1 divided by 1 over x to the 6, right? Okay. Well, that's the same thing as 1 over 1 divided by 1 over x to the 6, right? So now my rules of fractions tell me that if I'm dividing a fraction by a fraction, I take my divisor and I flip it and I multiply it as my dividend, right? So this becomes 1 over 1 times x to the 6 over 1. And that's how I went from this to this. We're doing some mathematical gymnastics. I just want to get those circles away because they bother me. Okay. So then our last step is quite simple, right? Because we're all over 1, so I have 3 x to the 6 is the end. Huh? All right. All right. Moving right along. Another one. Here we go. So, all right. When we have some sort of a rational expression like this, if I have some operation that I can do in my numerator or in my denominator, I need to do that operation first. Really, it's as if there's a parenthesis here, right? And order of operations says do parentheses first. Yeah? So that's what we need to do. So this becomes x to the negative 3 plus 4 power over x to the 8. So this is x to the first over x to the 8. And now I'm going to use property. Lost track now. Is it 5? What was it? It is 5? Cool. Somebody shook their head. Alright. So property 5 tells me that this is x to the 1 minus 8. Subtracting. So this becomes x to the negative 7th power, or 1 over x to the 7th by property 4. That's pretty good. Here we go. Ready? Okay, what in the world do these instructions mean? It says write it in the form k times x to the n, where k is a real number and n is an integer. What this means, it's very weird. It's a strange way of saying, hey, no variables. None? How did I write none? No variables in the denominator. In other words, if you have 1 over x, they want you to write that as x to the negative 1. That's what these instructions are. It says, hey, go ahead and leave negative exponents. That's what you're being asked. So this one is just 2 times x to the 5 plus 10 power, which is 2x to the 15. No problem. This one, though, is a little different. I'm going to go ahead and split it up. I can do that, right? Those two things are equivalent. So, they don't want me... Huh? They don't want me to leave it like this, right? So I'm going to change everything to x to the negative 8. Right. Moving on.
Helps understand anything.
All right. Again, I'm gonna break this thing up. And the only reason why I do that is to look at the x's separately. You don't have to do it like that. If you can see, yeah, I'm gonna leave the 6 out in the front, right? The coefficient of 6 is gonna be out there, and I'm gonna subtract these. That's fine. There are more complicated problems where I would not want to not break it up. Be careful with these types of things, right? Remember, we're subtracting negative 3. So that becomes 6x to the negative 2 power. And we're going to leave it like that because the instructions said so. My instinct is to write that as 6 times 1 over x squared or 6 over x squared. But they're asking you to leave negative exponents. Okay. So that's what we're going to do. We're not going to be like DJ Khaled. If they want us to do something, then we're actually going to do it. Yeah. All right. Now we're going to use property number. I have lost track. This is 3. We got to distribute. We got to raise everything to that negative 3 power. Okay. So let's go ahead and do it. So this becomes 3 to the negative 3 power over x to the negative 22 to the negative 3 power. Jogging like it's 2008. Yes.
I really hope they hear that.
The record button is on.
You were lighter than the salting crackers.
I was gonna go holier than the salty. All right. There we go. So what did I do? I wrote that negative exponent. So we can apply this to numbers as well, right? It doesn't just have to happen to variables. Right? 3 to the negative third power is the same thing as 1 over 3 to the third power positive 3. And then I multiplied negative 22 times negative 3, and I got positive 66. So then this becomes 1 over 27 over x to the 66. I'm going to write this over 1, right? So x to the 66 is the same thing as x to the 66 over 1. Only reason why I've done that is because I'd like to, I don't know, it helps me to see when I flip and multiply. Like, and if we make this one a little bigger, right, that says 1/27 divided by x to the 66 over 1. So when I flip, so I copy this down, I flip this and I multiply it. All right, and it told me, hey, we would rather have negative exponents. So we'll write it. All right, we just have one more. Yeah, we're gonna practice. So tomorrow I'll put a bunch of problems up. So, first thing I want to do with this is use the property that says that this is x to the 2 times n, so that will write that as 2n, right? And then we have a property that tells us that we would add our exponents, right? So, and you might say, well, that's weird because there's an n there. There's an exponent. There's a variable in my exponent. Well, we'll just leave it. It's there. It's fair to just write it like that. That is the end. And that's it, guys. Your homework is on the calendar.
Go feed yourself.